All right, this hangout is on the air live. Prepare to cue theme music.
Yep, preparing to cue theme music.
Cue theme music.
Cueing theme music.
Individuals, you are charged with capital malconduct. Anti-citizen status approved.
Hooray! I love that. Okay, so I hope everybody's excited to join our discussion. This is going to be an interesting topic that kind of irks me about a lot of modern religious philosophy.
Oh, yeah?
And it's this idea of equivalence, we'll say, or distinctions. So just to explain kind of the motivation of where we're coming from, a while ago, I once posed the question, what is free will? Because Christian philosophers just love to talk about that idea all the time. But anytime you ask them to just define it, they fumble all over themselves. Like they just don't know what that word means.
Or just stop talking to you.
Or they give tautological definitions for it. Or they just give, they can't tell you what free will is. So a good way to think about this problem of free will is just imagine you're in a room and I sit down a guy in a chair on your left, and to your right, I put another guy in a chair. So you're in a room, there's two dudes next to you, one to your left, one to your right. And I just say to you, one of these people has free will and the other one doesn't. What's the difference? How would you measure that distinction? And what's interesting is I've never really encountered a good answer to this question. Sometimes they might say, well, they have the ability to choose between options. So like, for example, I'll put down orange juice on the left and grape juice on the right. And I'll just say, pick which one you like. And the ones that can pick freely are the ones that have free will, and the ones that don't pick freely are the ones that don't, or something to that effect, which kind of begs the question now, or raises the question, like, what if I just programmed a really sophisticated computer algorithm to make these kinds of choices? Maybe it just flips a coin and randomly picks one or the other. Or maybe it will have some sophisticated algorithm that decides it likes orange juice over grape juice, and that's just the one it will tend to pick. Or what if we repeat this 1,000 times over and they just habitually pick the same one over and over? Are these the things that free agents do and free agents don't do? But no matter what answer you give, you always are left with that question of, well, what if I just came up with a computer program that mimicked that result? Would it have free will or not? And sometimes people will eventually get to the point where they have the courage to say, yeah, sure, that has free will too. But most Christians won't go that far. They'll just be like, no, the computer can't have free will because it wasn't made by God or something. It doesn't have a soul. But you as a person would have free will. But you're still left with that same problem. Well, how do I tell the difference then? And they just can't draw a hard distinction. So what this raises to me is an interesting analogy from physics, because this is where I more or less got the idea to ask these kinds of questions, is physicists do it all the time. So this brings us to an idea called the equivalence principle, which more or less says if you're given two options between things and you can't empirically tell the difference, then just give up. There is no difference. Just stop trying. They are one and the same scenario. So let's just illustrate this phenomenon. Like imagine you're in a spaceship, all right? So you're cruising around, you're Malcolm Reynolds in your Firefly spaceship.
Woohoo!
Woohoo! And I always visualize that scene where the Reavers are floating by them, right? Remember in I think it was the first episode of Firefly.
Oh yeah.
So they got the Reavers on radar and they're just floating by in space. And let's never mind the fact that if they were in space, they'd be going like 10 billion miles per hour. Instead, they're just floating by at like 10 miles an hour. A nice leisurely cruise by each other.
Along, sure.
So you look out your spaceship window and you see this Reaver ship floating by. And the Reavers in their spaceship, they look out their window and they see you floating by them. So the question is, which one of you is at rest and the other is at motion? Or maybe is there a kind of absolute motion that you're both moving relative to?
Well, sure. I'll just throw out the easy, naive answer. I'm moving, they're not, as they are drifting idly by me.
Okay, so you're the one that has the velocity and they're just fixed in space and you're going by them.
There.
Well, the problem is they can make that exact same argument for you. They're the ones who are moving along and you're the one that's stuck in space. Because from their perspective, they see the exact same thing. They see you just there as they whiz by, kind of like, watching the earth, the hillsides go by when you're on a train. I'm moving and they're sitting at rest. Or maybe it's the other way around. Maybe you're the one that's sitting there at rest and they're the ones cruising by you. Maybe you're the one who's on, the analogy would be like, maybe you're the one on the ground and the train is going by you.
Yeah. Okay. So it's got to be either or, right?
Does it? Maybe. So the problem is we can logically and philosophically talk about all these distinctions of one observer at rest and the other one at motion, and we can arbitrarily pick and choose who is who. But if I rearrange the roles of who's at rest and who's at motion, nothing physically changes. You both look out your window and you see the exact same thing. You see that other ship drifting on by you. So this leads us to a problem in physics where you have these logically descriptive scenarios. They're philosophically distinct. I can describe them using different words. But at the end of the day, I see, looking out my window, the exact same result. And we can even take this idea a step further by saying that there does not exist a single experiment you can ever perform that will differentiate between these scenarios. So this is a principle in physics that we just call the equivalence principle. Although strictly speaking, that name is left to more Einsteinian scenarios, but we'll call this like the Galilean equivalence principle. So you have all these scenarios that you can philosophically describe differently, but they all are empirically the same. So what we do is we just throw up our hands. They're all the same result. They're all the same thing. I cannot differentiate between them, so there is no point in even trying to differentiate between them.
Right,
No
so
experiment can do that.
Yeah, and if you can't differentiate, then the difference is nothing. And if the difference is nothing, they must be the same. It sounds
that's a great point. If you can't tell the difference, then what difference is there? See, I mean, that's a very deep question to me. Like, and you eventually have to just accept that if you can't tell the difference, then there just is no difference. So let's take this a little step further. One of Einstein's most famous thought experiments was imagining yourself in just a padded room. And you pick up a tennis ball and you drop it and it just falls to the ground. Now you have no windows. You can't look outside and see what's going on. All you know is there seems to be a force pulling things to the floor. So the question for you now is, are you in a uniform gravitational field, like on the surface of the Earth, or are you strapped to a bunch of rockets accelerating through space at 1g? So the question for you is, without looking out a window and seeing if there's a planet nearby, how would you differentiate between these two scenarios? Is there some experiment you would, what experiment would you perform to measure that difference?
And well,
here, solve physics for me. Break physics, actually.
give me a second.
Get out your calculator and tell me the answer to that.
If you can detect a gravitational field, I just need quantum field theory first. I just need to be able to pick those gravitons and I'll be good to go.
Well, the problem is, what if you do measure these gravitons in both scenarios?
Damn it.
Are gravitons even a thing? Are you sure about that?
I don't know. That's it. You're stuck. I mean, you want to test that gravity works? Sure. You toss the ball and it falls, and you want to say, are you moving faster than the ball when you let it go? When you experience the exact same thing, how are you supposed to say they're different? we fall into that again. Yeah.
Yeah, exactly. This is another application of the equivalence principle. And in the context of general relativity, all it says is there is no difference between those scenarios. You cannot measure that distinction. If you can drop the ball and see it drop, you can bounce light around in your room, and empirically speaking, no matter what measurement you perform, you will never differentiate between those two outcomes. And this is actually the key insight that leads to all of general relativity, from gravitational lensing to GPS to time dilation and space-time itself being warped by mass. It's just, it falls out logically from this simple declaration that those two phenomena, those two philosophical things, are equivalent.
That sounds like a big jump to me, but I'll take your word for it.
It sounds like a big jump, but that's essentially the core, the crux of all general relativity. That you can't differentiate between those scenarios. And I actually think it makes sense when you imagine a more generalized perspective. Imagine yourself just floating in that room. So the question is, are you floating just out in space, moving at a uniform velocity somewhere, or are you falling in a gravitational field?
Yeah, you could be falling to your doom from 3 miles up.
Uh-huh.
Nice little box where you don't see your impending doom coming, or there's just no gravity.
Right. And this is like, if you were inside the International Space Station, you would have this problem. If you just boarded up all the windows so you couldn't actually see a physical object nearby, you would never be able to tell whether or not you're falling or in orbit around Earth or just moving uniformly towards the Andromeda galaxy. No experiment you perform will differentiate between them. Those situations are totally equivalent. So it turns out this is how you get ideas like gravitational lensing. Because if you shine a flashlight on a wall, that light will bounce back and forth in straight lines from your perspective. But from the perspective of an outsider, if you're falling in a uniform or if you're just falling in a gravitational field, they will see the light bend back and forth from a straight trajectory to follow you.
Mm-hmm.
So the light itself is going to follow that gravitational field. And this is where this idea of gravitational lensing comes from. Because if it didn't, you would have an experiment that would tell you the difference.
Sure.
If light just went in straight lines, you would shine the light on a wall and see it bend all over the place. Thus gravity pulled you down, but the light would just go in straight lines.
Yeah, and if I recall, this is why many physicists were excited back in the 19-teens as a way of verifying Einstein's wacky ideas.
Yeah, exactly. Because this was potentially a distinction we could look for to differentiate between these scenarios. But it turns out, nope, you can't do that. The light will just follow you no matter which scenario you're in. So from the perspective inside your little box, you can't differentiate between these scenarios. So moving along, this is the idea, like I said, it's called the equivalence principle. And just stating it more or less generally and philosophically, we can say, given two scenarios, if there is no empirical measurement that differentiates between them, then there is no distinction between them. They are fundamentally equivalent from your perspective. And you can even go further and say it's meaningless to even talk about that distinction. They are in effect one and the same. I mean, and that's kind of like taking it a little far. I mean, you can meaningfully talk about a distinction, but if you can't measure it, then that distinction doesn't reflect reality anymore.
Well, yeah, if you say, honestly, if we're going to follow the equivalence principle and agree that we're dealing with the same scenario, if there really is no distinction, then it becomes rather pointless to talk about any distinctions from that point on.
Yes. And you kind of see this in the absolute motion problem, the Galilean equivalence. Because what does it mean to be traveling absolutely at 10 miles an hour to the left?
To the left of what?
Exactly. That's the problem, is you can't, 10 miles an hour relative to what? I cannot meaningfully talk about absolute motion in the first place. is when you really stop and think about it. You can only talk about the relative change in distance between things. So,
I would say in math, when you're just talking about your regular Cartesian coordinate system, the X and Y axis, where they cross, you have the origin point, the 0 by 0. That's a beautiful thing that many mathematicians get to take for granted.
Exactly. And the definition of distance itself in that Cartesian context requires 2 points. There's no such thing as the distance at a point. There's only a distance between points. And when you realize that's the meaningful thing to talk about.
Yeah, and you have the ultimate referent of which you measure all of the points by, and that is the origin point. So you have everything we measure in a Cartesian sense is relative to the origin point.
Well, not necessarily. It's relative to something. The origin is just convenient. But the origin can also be placed anywhere you want. So you got to be careful saying it's like the ultimate reference, because ultimately you can put it anywhere you want.
Yeah, I'd say that's what makes it the ultimate reference, but that's a difference in opinion.
Yeah. So the thing is, like, at the end of the day, what it kind of practically boils down to is I can't talk about absolute motion to the left. What I can say is here's a ship and here's me. And if I take a ruler and physically count off ruler spacings, I'll get a number. So that is a thing I can talk about. And I can see how that thing changes. So that's how I define velocity, is changes over time and so on. But it all boils down to there's no absolute motion. There is only relative motion between.
Yeah, and right there, I'd like to say, with general relativity, to say that space-time warps. I mean, talk about the ultimate middle finger to any amount of measurement, to say that space itself, your ruler will actually change length, and you won't be able to tell.
Right, but
itself will change, and you won't be able to tell.
Even though the ruler changes relative to other rulers, you can still take that ruler and go out and count ruler lengths between things.
Oh, it's a perfectly good ruler. It's just that you can't. There's nothing. The
result you get will be different from the result someone else gets.
Depending on how fast you're going and where you are and all the fun stuff of relativity. Yeah.
But there are, the whole point of those, there are things you can differentiate and talk about meaningfully, and other things that you just can't. Because if I can't, where do I take my ruler when I'm talking about absolute motion? How do I measure that? Where's my absolute motion measuring device?
Yeah, the problem is again, if you're stuck in a spaceship and you're free falling, or if there's no gravity, I can't tell the difference, because whatever measurement device I would have with me in that little capsule is experiencing the same thing I am.
This is actually what you said before, maybe I can measure gravitons. The answer is our predictions, if general relativity is correct, you actually will not be able to measure a distinction in gravitons. Either both scenarios will produce exactly the same, graviton count, or they'll both produce the 0 graviton count.
Exactly.
Assuming gravitons are a thing. Because if there was a distinction in this graviton count, that would kill general relativity. It means it's wrong. So that's a prediction we can state. Even, they're fundamentally equivalently the same thing. And even your graviton measurement device will not measure that distinction.
Even though it's a perfectly good measuring device, it won't measure anything given the scenario.
Yes, or both scenarios will produce the same gravitons, so to speak. Because gravitons are a product of that relativistic motion or scenario.
Right. So it doesn't matter, or doesn't rely on how well or accurately we can measure things. It relies on how or where that measuring device is relative to what we're trying to measure.
Yeah, and what differences do you expect to see occur?
Yeah, and if everything is within a closed system, well, that's it. You're done.
So that's kind of the physics background for the equivalence principle. And we saw it was motivated by this idea of free will. So moving along, the question is, what are some other philosophical problems that arise from this equivalence principle? So what we're going to talk about, is one of my personal favorites, is the problem of external world skepticism. And And this really solves a lot of problems when you invoke the equivalence principle, because it boils down to this idea of, here's a chair. I seem to be sitting in this chair here. But am I really? I mean, I'm experiencing it. I see it. I can touch it. I can feel its texture. But is there really a chair there? What is this chair thing really? Like, am I sure it's not just some kind of convoluted hologram like the holodeck from Star Trek? Or maybe it's a matrix simulation. I'm just a brain in a vat plugged into this simulation, and my brain is being fed sense stimulus through neurons and nerve impulses, but there really isn't a chair here. It's just this illusion of a chair.
No, I'd say you're wrong on all accounts. It's obviously the world in front of you is a collection of minute double helix coiled dragons that spin at different rates.
Yes, and depending on how they spin and breathing their fire, that will produce various textures and sights and sounds and feelings.
Exactly. See, you knew.
Or maybe I'm a brain in this skull thing with atoms grinding on it and feeling neuron impulses that way. That's a perfectly good option. Maybe it's a lucid dream. It's just my subconscious is very good at creating these elaborate worlds, but there really isn't this chair here.
Suffice it to say, given this exact same scenario, we can go ahead and concoct as many philosophical possibilities as to explain that scenario. But it's really not one, of course.
There are infinitely many possibilities for what this chair thingy is that I'm experiencing. So the question then becomes, well, okay, how do I know which is the correct one? And the problem with skepticism, any experiment I offer, I can always just chalk it up to the dragons and the brain in a vat.
Well, we just went over this whole equivalence principle. Again, if it doesn't matter, given the measuring device, if it doesn't matter that they are all equally explainable in that sense?
Well, they're all one and the same is the problem.
They all produce the same result.
Yes. So if I have a magical demon that's just created this world for me and is fooling my consciousness with all this stimulus, or maybe I'm a brain in a vat plugged into a mad scientist matrix simulation, or maybe, and they all are giving me exactly the same empirical sense experience, you finally have to stop and ask yourself, what the hell's the difference then? Why should I even bother drawing a distinction between all these things when I cannot measure it?
Yeah, we're back out into, if it's really the same, why are we trying to make these distinctions?
Yeah, and this to me is the ultimate answer to the problem of skepticism is, okay, maybe it could be all these things, and you know what? I'm completely detached from that reality beyond my immediate perception. So I'm just going to stop pretending I even know anything about it. I'm just going to focus on what do I know? And I know that I am definitely experiencing a distinct perception of hanging out, sitting in a chair, and feeling the cushions and the texture. Those are things I can meaningfully talk about. My immediate perception and my actions and their consequences.
Yeah. And, I don't need to talk about all the dragons that make up chairs and all the dragons that make up air. I could just say chair. I could just say air.
Well, they're kind of meaningless to talk about now, because I've just given up this idea of I'm detached from that reality. I can pontificate about it all I want, but I cannot tell the difference. So let's focus on the things I can tell the difference of. I can at least tell the difference between the varying sense stimulus I experience now. I have definite memories of things and an apparent ability to exercise choices and commit to actions.
Sure. Well, I want to back you up and say, I want to say this is a good thing why we have Occam's razors.
Ooh, thank you, segue dude. So yeah, you're kind of eventually left with Occam's razor, which says, what's the point of invoking all these dragons when they don't differentiate themselves from the demons and the mad scientist?
Yeah, and I could say chairs made of dragons and air made of dragons, or vice versa. I could just forego including dragons into this whole thing and I still get the same result. So why bother with the dragons?
Well, in effect, there's either some objective chair thing beneath me that I'm experiencing in a real world, or there is some illusion creating the perception of a chair, but isn't a chair.
Yeah, or maybe.
Or maybe. And so what's the point of adding these layers of convoluted illusion when I can just state there's something beyond me and there's this perception of it? What do you want to do with it?
Yeah.
So yeah, at the end of the day, you kind of also, here's another idea. It's like, what's the difference between the matrix and the Cartesian demon? They are fundamentally equivalent in every way. The only difference is instead of a mad scientist pushing buttons on a computer, there is a demon exercising magic to feed sensory stimulus to my consciousness. What's the difference? Can I measure that difference? If this was a matrix simulation, can I at least expect to see glitches in the matrix at some point? Like the deja vu joke?
Uh-huh.
Well, then you can always just say, no. Any glitch in the mad scientist is a inattentive loss of thought by the demon or so. So if you just can't measure the difference anymore, you eventually just have to give up. What's the point of drawing this philosophical distinction when there is no difference from my perspective? Who cares now?
It doesn't.
For all practical purposes, from my perspective, they are the same scenario. Right?
Yeah. What do you have to gain by adding on these layers of complexity?
Right. So in a sense, you just eventually kind of have to break down and say, okay, I'm going to not even bother trying to draw these distinctions because there isn't any by design. The whole point of these skeptical scenarios is to chalk up whatever your experience and your differences are to these nuances in whatever magical realm you're going through.
Mm-hmm.
So
I might as well say, mathematically speaking, I can say 1 + 1 = 2. Haha. Or 1 + 1 + 0 + 0 + 0 + 0 + 1 - 1 + 1 plus 3.
Actually, yeah.
3. Aha! It's 2.
That's actually an interesting way to put it. Like, what's a simpler math problem to think about? 1 + 1 = 2, or 1 + 1 + 1 - 1 + 0 - 1 + 1 + 2 - 2 + pi plus minus pi equals 2.
Really, is it the infinite sum of positives and negatives?
I can tack on all these infinite zeros there, but they add nothing, literally. So you eventually just kind of have to throw it all away and just say, like, I'm just not even going to bother accounting for this stuff because it all just undoes itself. At the end of the day, I have this one and this one that finally is giving me something meaningful. So that's what I'm going to focus on, and that's what I'm going to talk about. So in an analogy, by talking about the dragons and demons and brains and vats, you're adding nothing because they don't amount to anything tangible that you can experience at the end of the day. So from my perspective, since I'm trapped in my sense data, it is meaningless for me to even talk about those distinctions anymore.
Yeah, are you literally adding nothing, or are you figuratively adding nothing?
Philosophically adding nothing.
Philosophically, okay. You're literally philosophically adding nothing.
So this, to me, I think, is the final solution to the problem of skepticism, is just embrace it for what it is. I don't know. I cannot know, and I'm not even going to bother trying to draw that distinction anymore. All I know is whatever world I'm in apparently functions by rules and correlations, and I'm just going to work within them. That's what nature has given me, so that's what I've got to use.
It's what we're stuck with.
That's what I'm stuck with, yeah. What do I gain by trying to account for this other stuff? So let's now expand this to religious philosophy. This is really the ultimate motivation for this train of thought.
Here we go.
We talked about the free will problem. What's the difference between a person with free will and a sophisticated person like AI that doesn't have free will, but are otherwise perfectly the same in any other respect? What distinction would I look for to draw that difference? And I've never seen a religious philosopher or even a secular philosopher really tell me that difference. The only difference is that Secular philosophers are at least honest enough to say, hey, you know what? I'm not really sure if there's a distinction because I don't even know what free will is anyway. But not the Christians. But let's do another example. You're in a room, blocked off room. There's a table in front of you and 2 chairs. In the chair on your left, there's a person, looks like a regular adult human. And in the chair on the right, there's another ordinary adult-looking person.
All right.
One of these has a soul, and the other one does not. Like one of them is just a person. God has endowed that person with a soul. And the other one, God got pissed off and took that soul away. Or maybe they're just an android that's built like a Cylon. There you go. They're made out of actual flesh and blood and organs and brains, but they're artificially created by robots. So one has a soul, the other one doesn't. So here's the question. How do you tell the difference?
Oh.
I will grant you any measuring device in the known universe, too.
Are they okay with me dissecting them?
No, both of them say, no, please don't dissect me.
Nah, I'm alive and I have a soul, they say.
Yes.
Yeah. I'm stuck. Yeah.
Right. And I'm stuck too. You could imagine a solo-meter, like a Geiger counter or something, where you wave it around at the person and it goes beep, 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 beep. You have a soul. Congratulations. And then you wave it at the other person. It's like, no soul. I can kind of imagine that.
I'll have to come back and say, okay, so what's a soul? What is a soul? What am I looking for here?
Well, yeah, that's what the crux of this problem is what is a soul? I mean, it's this ectoplasmic infusion of life into a thing. So are living things, do those have souls and non-living things don't? So is that what a soul is? It's just either alive or it isn't? Because that's something I can measure. But again, Christians don't really think that. They'll say, you have a soul, but a cockroach maybe doesn't. Or a tree doesn't have a soul. Or that moss that grows on the underside of your refrigerator, that doesn't have a soul.
Sure. But then you have lots of apologists that will go on to say that souls are not made of any physical material.
Okay, now here's the next problem. Okay, same challenge. Something on your left is a physical material object, and somewhere in this room is an immaterial object. How do I detect an immaterial thing? And if I can't detect it, how do you know they exist in the first place? What is an immaterial anything?
Well, quantum mechanically speaking, all material is really just energy. So if it's not a material thing, it has no energy. And if there's no energy, I'm lost. I'm just making up.
I mean, I can create potential energy just by lifting up a tennis ball. So is that an immaterial property of that tennis ball by the mere virtue of having a height relative to a gravitational field? Is that immaterial now? What's the difference? What's an immaterial thing? Show me an immaterial anything. But then, of course, they'll say, well, by definition, it's not in space and it's not in time and it's not made of anything. And you're like, okay, how's that different from nothing? I could just do the same problem. Here in this chair is nothing at all. But in this other chair is immaterial soul essence. Okay, tell the difference. Which one's which? Which chair has nothing in it? Which one has the soul that's floating there? How do you know that anything exists outside of space and time? What does that even mean to talk about something that is nowhere, does nothing, and isn't made of anything? Because that sounds an awful lot like just nothing at all.
So you're telling me it's something I can't measure with a ruler or with a stopwatch at all. So it's not measurable.
Right. Of course, then their favorite example will be like, well, love is immaterial. So what do you say to that?
No, it isn't.
I mean, I can experience love.
I've experienced love, and I know My girlfriend experiences lots of chocolate when there's love.
Well, yeah, a good example then is, okay, what happens if I drink alcohol? And it changes my sort of perception on reality. So if I can induce perceptual changes by committing to material actions and consequences, how is that immaterial? Like, so they love to point at qualia itself. Sense data is an immaterial stuff. But then, like, what does that even mean? Okay, so I can at least see I have this immaterial sense data. What about a person sitting across from me? So this leads us to the pee zombie problem. You've heard of a pee zombie, right?
It just sounds like a zombie that has no urinal control.
So same problem. On your left is a human being, or what looks like a human being. You can poke them and they'll be like, ow. And then you can ask them questions. They'll tell you their life story.
Wait.
On the right is another one. You can tickle them and poke them and talk with them. The only difference is one of these people experiences qualia, while the other one doesn't. They're just like a machine processing information, but doesn't, quote unquote, experience anything.
Oh, come on. Really? Who came up with this?
Philosophers.
So there is a being in front of me that acts and looks and reacts like a human being in every conceivable way, but isn't one? Is that what you're trying to explain to me?
But just it looks and acts and reacts, but it doesn't experience. So if you hold up a red piece of paper, just has a big red thingy, like a red rubber ball maybe, and you say, what color is this? They'll look at it and they'll say, oh, it's red. But deep down, if you could crawl inside their perception, there would be nothing. So they can differentiate red from blue, but they don't experience red from blue.
Oddly enough, this is starting to explain a lot of my stoner friends. There. Okay, that's my joke.
So again, we have the problem of the equivalence. You've defined a thing that has all the properties of something with qualia, but then doesn't have qualia. What would that look like? It can tell you the difference between red and blue and appears to be right all the time. It just doesn't experience it. How is that even possible to experience red from, or to differentiate red from blue without actually experiencing it?
It sounds like Christian apologists haven't really thought that one through.
Right. So
come on.
Ultimately left. They love to come up with all these wacky ideas of immaterial, timeless, spaceless things, but you're always left with that problem at the end of the day. Well, okay, what is it really? How do I know it when I see it? You know, am I absolutely moving to the left at 10 miles an hour, or am I just at rest and the rest of the universe is moving to me? I don't know. What's the difference? Is this thing have a soul and that thing doesn't? What's the difference then? Otherwise, they're perfectly the same. What am I looking for in that difference? One will just be evil.
And in the case of your pea zombie, it looks and talks and acts, and if it walks like a duck and talks like a duck and quacks like, but trust me, don't worry, this one isn't a duck. Really?
Yeah, that's actually a great analogy. It's you're basically saying it looks like a duck, it walks like a duck, it talks like a duck, it acts like a duck, but it isn't a duck. Then what the fuck is it? How do I tell the difference then between a thing that looks and acts and behaves exactly like a duck but isn't a duck?
It's a pea duck.
It's a pea duck. There you go.
It loses any kind of self-consistency when you're just trying to play with definitions and trying to you're gonna say it's a human for all intents and purposes, except in the way you cannot perceive it isn't.
Yes. So this is actually, there's a fallacy for this. There's a word, an actual official formal logical fallacy for this, for this problem, this idea. It's called the distinction without a difference. When you postulate two things as being different, yet in such a way that there's no way to actually tell the difference, you have drawn a distinction between two things that are not different, two things that are the same thing, effectively.
I swear there's a fallacy for everything.
So the idea of a soul, of P zombies and free will, these are all distinctions without a difference. If you can't tell me how to empirically measure that soul thingy of which you talk about, then you don't know what you're talking about. You're babbling gibberish at me. And when I start thinking about these ideas and and experience them and talk with people about them, I really gain a deep, profound sympathy for logical positivism. Because one of their central theses was this idea that if you can't like empirically tell me what the difference is between these two things, then it's not only is it just like a distinction without a difference, you're literally speaking gibberish at me. Like that was one of the things they probably took a little too far. Like I can understand what you're saying, but you're also overcomplicating things if there's no difference. But they took it one step further and said, it's literal gibberish to me if you cannot empirically verify what you're talking about. Which I kind of sympathize with. I can see where they're going. Maybe that's a little extreme, but you kind of see where this problem is that they're getting at. If I can't measure a soul versus not a soul, then what's the difference? What is a soul really? Is it even a thing?
You don't need a different definition. You don't need to say there's such a P zombie and a human. No, they are just two. Now you've unnecessarily come up with another label for the same thing.
Yes, and that's just perfect. That's what the equivalence principle says. You've drawn a distinction between two things that have no distinction. Therefore, they are the same thing. So if I told you, here is a thing that looks like a person and acts like a person and has a soul, and here's a thing that looks like a person, acts like it, but doesn't have a soul, you've just described two things that are the same. I might as well have just said, here's a duck and there's a duck.
Mm-hmm. Oddly enough, this does remind me of a famous quote. I think it was Poincaré, to say that mathematics is the art of giving new definitions to old things.
In a sense, yeah. Like, so what's the difference between what's the difference between a being that can process information and respond to stimulus and laugh and cry and tell me its story and be tickled and feel pain or flinch when it's poked, versus a being that can do all those things but doesn't really experience them?
Even though by definition you just said it experienced everything.
Which is the problem. Like you just if it flinches when you poke it, but it doesn't feel pain, then what just happened?
If you're flinching to some kind of sense, if you're reacting to sensory input, then I want to say you are experiencing that sensory input in order to react it by processing it.
Yeah, it's kind of like, sounds like by definition. So even if it was a computer program that's designed to flinch in that sort of mimicked response, well, it still felt that, it processed that data. Sure. And then made a decision accordingly. Like, what is that if not qualia itself? Is that interpretation of that sense stimulus?
Yeah, you could say it's a soulless computer just reacting to the stimuli that you gave it. But damn it, if you wave your hand fast enough in front of my eyes, I'm probably going to flinch, and I won't have any control over it. Flinching is is not a conscious response.
Programmed response in you just as much as it is in the computer. The only difference is one might be made of silicon in a sense, or the other one's made out of neurons. Like what do neurons in your brain do that a computer algorithm can't?
Exactly.
Then they have a soul. Neurons have free will, but computers don't.
But they're programmed sometimes to have it.
Yes. So there's two more sort of thought experiments to kind of go by here.
Okay.
Not really thought experiments, but just examples of these distinctions without a difference. So one really common one that's really bugging physicists today is, what is the correct interpretation of quantum mechanics? You have, the Copenhagen interpretation, you got the many worlds interpretation, there's the pilot waves and some other ones that are more obscure. And the question is, like, which one's which? So the standard workhorse interpretation is Copenhagen. And all that says is the underlying essence of reality is ultimately governed by probability.
Yeah. That we ultimately live in a indeterministic or stochastic universe.
Now, obviously, there's problems with that in that we don't know what a measurement is, because a measurement is when you collapse the probability to a certainty.
Yeah.
The particle is definitely here and it was going that way. But nobody knows what a measurement is really.
Or the measurement changes as you go.
Yeah. But then you have the idea of the many worlds interpretation, which simply says there is no collapse of wave functions. It's not even a thing. It's just these infinite branches of things that are just falling out because wave functions never collapse. Just any outcome of that wave function that can happen just does happen, which is effectively what happens when you do quantum mechanics but ignore wave function collapse. So that's actually Sean Carroll's big claim to fame, is he always likes to point out, hey, I just have one less assumption in my interpretation than you guys do. Sorry if it just gives a weird result that makes no sense, but that's just what the math is saying. It's because I just did away with this trivial assumption or this nebulous assumption that doesn't mean anything.
Mm-hmm.
So, but this is actually a big problem in quantum mechanics, because at the end of the day, we can't tell the difference between all of these formulations and interpretations. They all produce empirically the same result. When I shove photons through a double slit, I get an interference pattern that blips one at a time as photons strike it. And that's it. That's all I can meaningfully talk about.
There's a whole ode to quantum mechanics video showing that.
There kind of is, actually. I'm sure some of you out there have seen it.
On your channel. It's
on
there.
The channel. The Anti-Citizen X channel has an ode to quantum mechanics. But that's, the equivalence principle strikes again. And this is an openly acknowledged problem for physicists, is all of these interpretations are kind of logically weird and counterintuitive and make no sense, but they all ultimately just lead you to the same empirical outcome. So we'll just pick the one that seems to work for now and make sense and is easiest to process until at such time you can devise an experiment that ultimately differentiates them.
Yeah. What else can you do?
Right. There's nothing you can do.
Until there's a measurable difference, there's no difference.
Right. And so therefore, by Occam's razor, I'm going to just work with the one that's simplest. It doesn't have the baggage associated with it.
Yeah. I mean, Occam's razor is a really nice way of saying, use the minimal number of explanatory factors, and anything beyond that is by definition unnecessary.
Yeah. So finally, how about this one? Okay. We live in a world created by God, a God who loves us and cares for us and wants to build a deep personal relationship with us, but will not actually appear to us or talk to us or intervene on our behalf in any measurable capacity.
Well, now it just sounds like a whole big string of +0, +0, -.
All the things, God is there and definitely exists and wants to do all these things, but doesn't. But does them all in such a way that you can't tell that he's actually doing them. Or he's just not there at all.
Yes, and differentiate that between no interaction at all whatsoever.
He's benevolent, he loves you, but for some reason he created smallpox and has a good reason for letting that kill everybody and scar them for life, and didn't intervene to save us from it. Or he's just not there.
And it just sucks to live in the world we
Occam's razor, guys. Like, which are we going to do with? Because, another way to think of this is when you get cancer, are you going to pray for help or are you going to go to a doctor? Or maybe you'll do both. But then I have to ask, okay, what did the prayer really do for you? Can I compare prayer versus non-prayer and see some objective difference? And the answer to that is no.
Whoa.
So then it so why pray in the first place if you know in advance it won't empirically manifest in any tangible way?
Well, hold on. There have been experiments to see, that is a measurable distinction that we can make. If you pray and get better as opposed to pray and don't.
Right. And one of these is consistent with a world where God's in it, and the other is consistent with the world that doesn't have a God in it. Which outcome do you think we experience?
Well, okay, so then you have to go back and make the assumption, if you pray, does that mean God will answer that prayer and make you better? Or does it mean God will acknowledge the prayer, but choose on his own to react to or not.
Yeah, and that's the problem, is where Occam's razor comes in again, where Christians want to have their cake and eat it too. They definitely want to have a God that exists and looks out for them, but they're also stuck with the fact that it cannot be differentiated in any capacity from a God that just doesn't look out for them.
Or differentiated from no God at all.
Right.
Stop talking about God.
So
sometimes cancer gets you, sometimes it doesn't.
yeah. So anytime you're left with the problem of like prayer doesn't do anything, well, they have to invent all these convoluted excuses of like, well, God will just do it in his own time and in his own way, blah, blah, blah.
Oh,
well,
no.
What's the difference?
Mysterious ways, my friend.
Like, if I cannot objectively measure that distinction between prayer helping me and prayer not helping me, then there is no distinction. Prayer will not do anything.
Again, yeah, it really does come down to, if there's no difference, they must be the same.
Yes, they are equivalent problems. So this is a point that was made in one of the philosophical failures videos. You know, a God that can just only be concluded through argument but cannot be demonstrated is fundamentally equivalent to no God at all. They are the same. When you say a God that loves you but won't do anything to actually help you or save you is equivalent to no God at all. It's like saying, you know, there's a man in your closet who's keeping an eye on you and is looking out for you, but will not intervene in any way when you get in trouble. And if you ever try and look for him and find him, he hides even more.
Yeah.
What's the difference then? Or I guess this is actually the classic invisible dragon in my garage problem. You know, there's a dragon in my garage that breathes fire, but it doesn't produce heat. It's incorporeal, so you can't touch it, and it leaves no tracks in the ground, and so on and so on and so on. Like, what's the difference then? You have a dragon with all these properties that cannot be measured or differentiated from no dragon at all.
Mm-hmm.
So you eventually do have to just state the obvious, that there is no difference. You've just effectively described one and the same scenario.
Yeah, it's one of those things where, is there a dragon? Is there not? Is there a God? Is there not? That fundamentally, I want to say, this equivalence principle is allowing us to really just say, not just they're the same, but really, who cares?
Well,
why are we talking about? Yeah, it's we're going on beyond any kind of distinction. We're going we're going into an area that becomes a completely fruitless endeavor. What?
It's pointless complication. You're adding layers of complexity to something that doesn't help you make a decision at the end of the day.
It's still just a chair in front of you. It's still just your garage. Maybe it's just a person, damn it. Maybe we have souls, maybe we don't, but damn it, we're all just people, and that's all we have to work with.
So, okay, what are some things we can differentiate? Because we keep knocking on equivalent things. What are things that are not equivalent? Ooh. So one actually good one, let's talk about a philosophical idea that does have a measurable distinction. And that is the idea of determinism versus indeterminism.
Yeah, okay, yeah.
So, you imagine I hand you a box with some balls in it, and you shake it up and they bounce around and they do things. And I tell you,
done this to me before, so it's not really hard to contemplate. Sure, okay.
Did you just make a dick in a box joke?
I wasn't trying to, but damn it, now it's out
there. No homo. Although it's legal now. Remember that. That's what I remember. Sorry. As I was saying, I hand you a box and there's some like little steel balls in it. And you can shake it around and you see them bouncing and doing things. And I hand you another box and it looks identical. You can shake it around. There's little balls in it. However, I tell you, one of these boxes is deterministic and the other system in the other box is indeterminate. Otherwise, they are completely identical.
Okay.
What would you look for to measure that difference?
Well, I can see where the steel balls are relative to their placement in the box over time. Do I get to at least set an initial condition? Do I get to place all the balls in a corner.
Well, you're getting ahead of yourself. The question you should ask is, okay, what is determinism? What does that mean?
Well, sorry, I know what determinism is. I was just trying to figure it out. Okay.
Just because we already had this conversation off camera doesn't mean you can assume that we've already had this. Never mind.
Because we already have had courses on what is deterministic. Let's back up. What is determinism as opposed to indeterminism?
Okay, determinism says if I set up all the initial conditions to some measurement, like I line up all the balls in a row and I kick one off to the right and collide it with the others and track all their motions after a few seconds and they all come to a rest, they will have some final state. And then if I repeat it, I set it all up again perfectly to the same initial conditions as before, to the best as I can, and I kick it off and track them all and watch their positions, that final state will be absolutely identical to the initial trial. And I can repeat this an infinite number of times and always get the exact same result.
Yes. How Newtonian?
That is the definition of a deterministic system.
Sure.
Equivalent inputs, initial conditions, will always produce the same final conditions. In contrast, an indeterminate system will not do that. I will set up the initial conditions absolutely perfectly, kick it into motion, and then the final state will be totally different.
Every single time.
Every single time. It will just be different.
Well,
and
who
different.
knows? It could be
or maybe not even every single time. Maybe it'll repeat itself a lot.
Yeah.
But then it'll just do something different.
Maybe the second time was the same as the first time just by sheer coincidence, but then when you do it again, it's different. So I want to say the big difference is repeatability.
Correct. That's more or less the definition of determinate. So you can actually run that experiment, set up all the little bowling balls or steel balls or whatever, and just kick them into motion and track their positions, and then repeat it and do it again. And if I get the same result over and over and over again, I can conclude, okay, this is a deterministic system. But if I do it and different things keep happening, it'll be indeterminate.
Oh yeah, and I'd say it gets a little funny if you're dealing with a deterministic system, but the initial conditions are very sensitive to their terminal states.
Right. That's actually the definition of a chaotic system. A minor perturbation in the initial conditions will create a strong perturbation in the final result. But it's still deterministic.
Absolutely. And I'm just pointing that out because I like dynamical systems.
Yes.
So
that is an interesting idea, but it's a little off to the side. But it's an interesting sidebar.
It can be acknowledged. That's all I'm saying.
Yes.
We can move on.
Now, an interesting question. Are there systems in nature that are indeterministic? Because we know if I play pool and set up everything with the billiard balls perfectly, I can create reproducible results.
Yes. But then again, as mentioned earlier, the double slit experiment.
Yes. If I do that exact same thing with the double slit experiment, where I shoot photons down a tube at a double slit and measure where they appear on a detector, it does not matter how precisely you set up the initial conditions. You will, in fact, get a different outcome every time.
It's weird, but that's the world we live in.
That is the Copenhagen interpretation of quantum mechanics that we mentioned before. You can try as hard as you want to perfectly replicate initial conditions, and the outcome will just be different. You'll get a different measurement, and nothing you do can refine that precision.
Yeah, and this is not for the lack of making accurate measuring devices here.
Right.
It's blazingly accurate nowadays.
It's a fundamental property of nature itself to be indeterminate, it turns out. So, of course, now when you make particles big and get conglomerations of like baseballs and things, that indeterminism is still technically there, but the variance gets squished down to such a tiny little fraction that it's practically determinate.
Yeah.
So we actually live in a world that is indeterminate, where there are things that behave indeterministically, and then there are things that behave deterministically, and we can draw that distinction. It is a meaningful distinction that I can measure and experience.
Sure.
So it is a distinction with a difference. Fancy that. Here's another good one. You know, if I place something in a chair next to you, and on your left, and another chair on the right, and I say one of these things is a human and the other thing is not a human, tell the difference. How would you do that?
Oh, well, I have a crude understanding of what humans should look like.
Uh-huh.
So I'll start with that. Is it symmetry? Oh no.
Bilaterally symmetrical. Yes, it is.
There. Oh, it is. Okay. Does it have mammalian characteristics?
Yes, it does.
Oh, okay.
Memory gland, memory papilla.
All right, and it has heterodontous teeth. Different.
I don't know what that means, but no, it doesn't.
Oh, well, no. Humans, they have different kinds of teeth.
Oh, okay. But the thing on the left does, and the thing on the right doesn't.
Oh, there you go. That's a difference.
There you go. Okay, I just differentiated a human from not a human.
From a human that had like all shark teeth or all snake teeth or something. That would
Barring some extreme scenario where it was a human and had all its teeth ripped out.
Yeah.
It did at some time.
Well, okay. If it had teeth at some, yeah. Oh, but
Okay,
then,
you can reasonably draw a distinction, right?
Yeah, but then what if you were actually fooling me? and they are two humans, but one is a toddler and does have a different shape than the adult.
Well, then we just have to kind of refine our distinction. There's differences between adult humans and young humans, right? Adolescent humans.
Okay, so I definitely should have asked the qualifier. Are they both adults?
Yeah.
But then the again, this is coming back down to how accurately we are measuring things.
Yeah. And so, you can also see how sometimes there is a distinction with a difference, but the boundary may be a little fuzzy.
Yeah. Oh, yeah. Pluto, the planet Pluto.
So this is a great question. Same problem. You're out in a spaceship, and to your left, you see a big giant thing. And to your right, there's another thing. And I just tell you one of these things is a planet and the other thing isn't. What's the difference?
Okay. Well, do I know which one's the planet?
Well, you have to ask yourself first. Okay, what is a planet?
Yeah. Okay. What's a planet? So, planet is a thing way bigger than I am.
Okay, so let's say that more precisely. Is an object big enough to compress itself by its own gravity into an approximately spherical shape? That's rule number one.
Well, that's what's going to happen with it. Yeah. Okay. So it's big enough that gravity will conform it to something that of a spheroidal shape. Yeah.
Right. Okay. What else? You can measure sphericalness, right?
Yeah.
Okay.
So no matter what perspective or vantage point I have, it looks like circular. Okay.
Okay.
All right. That's done. Oh, okay. So
orbit around a parent star.
That was my next one. So yeah, are we just out in intergalactic space, or are we actually in orbit around a star?
We are in orbit around a star.
Okay. All right. Well, does what about other objects as they come along? Do they fall into its own little gravitational well, or are they just bounce each other around?
I don't know what you mean.
Oh, okay.
In other words, I think what you're trying to say is, has it cleared its orbit around that star of all other significant debris?
That one, yeah.
Yeah. No, it hasn't.
Okay. Well, now we're getting down to something. It sounds like it's not a planet.
Bingo! And that's why Pluto is not a planet, but the Earth is. Those are some of the key definitions that you look for in planet versus not a planet.
Yeah, it's out there in that whole Oort cloud thing or bobber.
Yeah, it has not cleared its orbit of all the other crap floating around it. So that's why the asteroid belt has large objects in it, but they're not classified as planets because there's other comparatively sized objects in that same orbital zone.
Yeah, so at best you get to be a planetoid, I suppose.
Yeah, so actually Ceres, I think, is the largest asteroid, and it's like the size of Arizona or something. It's pretty big and it's round, but it hasn't cleared its orbit of all the other trash. So we just call it a planetoid or an asteroid in a sense.
Uh-huh.
So that's the distinction. We've defined a distinction that we can tell the difference within reason.
There we go. It's the ultimate game of 20 questions where...
Yeah. You define the properties of the thing, and then you just empirically measure all those properties until you're down the list. But if you come to a point where there is no empirical difference between that property and not that property, well, then why is it on the list? Right?
That's a fair question to ask. Yeah.
So that's kind of where this boils down to. When you have a checklist on your definitional set that just cannot be measured, well, then you can't tell the difference anymore. So it doesn't matter whether it's there or not, and it's a distinction with no difference. So let's kind of wrap up here. We're getting out of time. So the take-home point is fundamentally the equivalence principle, which states if you can't tell the difference between these two things, then there just is no difference. They're fundamentally, philosophically the same thing. Maybe not philosophically, but empirically, practically, there's no difference.
Sure. That shouldn't be a hard take-home point. That's something that makes.
And yet Christians just struggle so hard with this, with all, just supernatural ideas in general fall into this pitfall of you're describing things that can't be measured or differentiated, but are definitely there and distinct from things that aren't there. And well, it's like, how do you know that? You're obsessing over something that can't be differentiated.
Yeah. So
sure that it's there in the first place.
Yeah, and even from a physics standpoint, if it is incapable of being measured, then it is incapable of existing.
In a sense, I think I see what you're going with that. Like, if I can't measure the thing, does it even exist in the first place?
Well,
like
I mean,
the invisible dragon in my garage. I can't generate a single manifestation of that thing in any way.
Yeah,
so it
and
doesn't really exist.
Yeah, and if you want to say, here's another thing that measures out to be a human in every conceivable measurement method, yet I'm going to say it's not a human? No.
No, you can't do that. Yeah, it kind of works both ways, doesn't it? So the difference between a thing that's there and a thing that's not there, or versus a thing that, well, that made no sense. Sorry. Yeah, if you're just defining properties that I can't tell the difference, then what's the difference? But anyway, let's look at some comments before we go. Otherwise, we'll just wrap things up. Let's check. Are there any good questions in our comment section before we finish? Ask me anything. I would say free will is when you can't determine the choices of the subject 100%, not even if you have knowledge of everything before the choice. So that sounds a lot like determinism versus indeterminism. So in a sense, this is actually an interesting idea. I thought about it once, but it sounds an awful lot like saying, if you have free will, you'll behave deterministically. And if you don't have free will, you'll be governed by rote probability.
But that... Yeah.
So again, it's like saying, here's apple juice, here's orange juice. Which one do you prefer? And if they just are randomly flipping coins, okay, you have no free will. Or no, you do have free will, effectively. That's what they're saying. That if I just rig like a photon counter in a double slit, and every time it lands to the left of the slit or versus the right of the slit, that's how I base my decision, I have free will. So that's the problem with that definition, is you effectively reduce free will to rote randomness. And if you're okay with that, then that's what free will is to you. But you've drawn a distinction between free will and randomness. What's that difference? And if there isn't any difference, well, then free will is just rote random behavior. So it is kind of a tempting definition, but that's where I think it breaks. But thank you, Jenny, sir.
Yeah.
Sorry, I keep interrupting. Go ahead.
No. Okay, so Molzon.
Molzon.
Yeah, there will always be elements of the universe which are beyond our current control and investigation. You require experimental control to verify something scientifically. This is part of the reason you can't scientifically verify God or metaphysical things. You can't put God in a flask, as Eugene Scott says.
Well, do you want to field this one? What are your thoughts on that?
Well, if they're really out there, then they're not. Then theoretically, they're not beyond being measured.
Well, yeah. If I can't measure God in some way, I can't shake his hand, I can't meet him, I can't talk to him, I can't elicit him to help my cancer go into remission. The problem is, if I can't put him in a flask, how do I even know he's there in the first place? I mean, this is something a lot of Christians and theists will cite as like a virtue of God as a concept, when it's a complete vice. You've defined it as something that exists but cannot be experienced in any way. So what's the difference between a thing that exists but will never be experienced and cannot be experienced versus something that just doesn't exist at all?
Yeah, and that goes back to our equivalence of that. The equivalent between something that you purport to exist and something that doesn't exist at all. If they're really equivalent, it becomes a meaningless question. But to say, I mean, like a lot of people like to do, is to say God is defined as this thing, this immaterial thing that exists outside of our space-time. Well, what's that?
Here's another one. Immaterial things such as the Higgs field have been verified. Okay, stop. Molzan, when you talk about the Higgs field, you are talking about a material field. At least that's what most Christians and religious theists will define it as, because it's an actual particle governed by a field theory that I can measure and has been measured. Yeah. It is the thing that endows particles with mass. Now, if by definition you say that which does not have mass is not material, okay, so photons, are those immaterial? What if I can convert that photon into a massive particle, like a positron? Which is actually something that does happen. Like, so this is something where I'm not really, you want to draw that distinction, great, but a lot of things are now immaterial that are perfectly mundane and ordinary if you do that. Even a virtual photon, which technically exists, but it has no space, and it comes into existence, or it doesn't occupy space, it has no mass, but it comes into existence and then leaves. You can at least measure an effect of that by the simple fact that charges attract and repel each other. Those virtual photons are the things that give rise to the force, which is something I can measure. But yeah. Christians will call that immaterial, or no, they'll call that a material process. So again, maybe you want to draw that distinction, in which case lots of immaterial things exist. But all you've done is equate immaterial to does not have mass or does not have a precise position in space. Well, technically, an electron has no precise position in space. It's governed by this spread out wave function. Does that mean electrons are immaterial? So,
the cell phone when it needs more juice from its battery. Okay.
So this is another thing that happens when Christians get too greedy in their definitions. They actually try to assign a hard definitions. They inadvertently make everything immaterial, or everything suddenly becomes material, or everything is immaterial. Like now, what's the point of even drawing that distinction between material and immaterial when everything now falls into that category?
Again, when quantum mechanics already tries to deal with that, when you talk, I mean, there really is no such thing as mass. There's just a whole lot more energy, and you want to talk about all particles just have a particular amount of energy, of electron volts.
Or how about thoughts are immaterial? So now here's an interesting question: is baseball material or immaterial?
No, baseball's it's a ball that you can hold.
No, it's not the ball. I mean the process, the game itself.
Oh, the game. Okay.
And this is something that you'll see, like Cy ten Bruggencate talks about logic as being immaterial. Well, logic is not a thing. It's something you do. If I were to ask you, where is a baseball game? Well, I can look at the field and I can see the players and I see the ball bouncing around and they're doing stuff. But where's the game? Well, the game is the process itself. Is that an immaterial thing? Well, by that definition, sure, then baseball is immaterial. And is that really where you want to go with this?
Well, no, I could also argue that it's material in the sense that when I see a bunch of people acting in a certain way under a complete interactive dynamical system that are following a particular set of rules, then by definition, they are playing baseball.
Yeah, so they are material things doing things in a certain way. So
How is that
How
not
is that immaterial? So it's immaterial if material things are doing things. That things that they're doing, that material things do, are not material.
Yeah, as opposed to a bunch of baseball players all happily asleep on the field. I mean, there you go. There is a measurable difference and it's a material difference at that.
Yeah. So this is a problem again with this material versus immaterial distinction. It just I don't know where that line is, and the word just has no meaning to me. Oh, anywho, do you have any closing thoughts for the kids before we go?
A lot of these scenarios like free will, a soul, God, all these things have easy definitions. But then when you really start trying to make a distinction that these definitions have in our reality, with a little bit of extra thought and trying to be more clear with these definitions, as with many things in life, again, like with Pluto, we once considered it a planet until we came across a need to be more precise in our definition, to make more distinctions. And when we come across things where we lose the encapsulation of what we're trying to describe, then it's a meaningless definition.
Sorry. Andrei Larionov says the solometer is that device from the Star Wars prequels that measures midichlorians. Duh. If I had that, I'd easily be able to detect souls. So if I can measure your midichlorian count, I can tell whether or not you have a soul. I like that. That sounds great.
It's obvious in retrospect. Yeah. Oh, and
I don't think Christians would go for that definition, though.
Probably not. Logan Blacksill, quick correction: rogue planets do not orbit stars, but are considered planets. Oh, okay, rogue planets. Well, there you go.
Well, I would say that's a difference now between a planet and a rogue planet. Would be a planet that has all the properties of a planet but isn't around a star. Hence, that's a rogue planet.
But yeah, but there you go. So I'm happy to take random people on YouTube to correct me on my astrophysics.
Well, I think it's kind of an exception that proves the rule. Because you have a checklist of all the things that define a quote-unquote planet. And one of those is an orbit around a star. So if it has everything except that orbit, it is quote, a rogue planet now.
Yeah.
So, it's like a planet. It's very similar, but doesn't technically qualify as a planet. It's a rogue planet, which is fine. It's a perfectly meaningful distinction, I think. But it is an excellent kind of point to bring up that, we can split hairs as much as we want and give everything names as long as there's a clear distinction that we can measure.
Mm-hmm.
So on that note, thank you everyone for joining us and have a good day.